Some airports will include a warning about wind shear if it has been reported by a pilot on either approach or departure, or even if it has been forecast. This will simply be denoted by the letters WS followed by the details of the report. More information about the report will be broadcast on ATIS, Volmet, or by air traffic control themselves. A trend forecast is valid for 2 hours after the time of the observation and is attached to the end of the METAR. It gives the change in conditions expected in relation to the actual weather. However, trends are not routinely produced at every aerodrome issuing METARs. The coding used closely follows the TAF code, and for more information on this, refer to the next lesson on decoding the TAF. One major difference with the trend is that the code NOSIG is used to denote that no significant change is expected in the next 2 hours. An additional 8-figure runway state will be added to the end of the METAR when there is snow or other runway contamination. This is sometimes referred to as a SNOWTAM and will be produced by air traffic control. It takes the form runway designator, runway deposits, extent of runway contamination, depth of deposit, and finally, the braking action required. An equals sign will appear on the METAR to denote the end of the message. Let's work through this final example. The ICAO letters identify this as being a METAR for Paris Charles de Gaulle Airport on the 8th of the month at 20 minutes past 8 in the evening UTC. The wind direction is 150 degrees true with a 10-minute mean speed of 16 knots. A maximum gust in the last 10 minutes of 28 knots has been recorded. The directional variation in the last 10-minute period was between due east and due south in degrees true. The visibility from the observing point was 4,500 meters in a light snow shower. The cloud was few at 500 feet and broken cumulonimbus at 1,100 feet. The air temperature was +2 degrees Celsius and the dew point -2 degrees Celsius. QNH was 989 hectopascals with thunder in the last hour. Wind shear has been reported from runway 12. The trend in the next 2 hours is for an improving situation, with the visibility increasing to 10 kilometers or more and the cloud becoming scattered at 1,300 feet, but with cumulonimbus cloud remaining. A variation on the METAR is a special report. This will take the same format, but will be denoted by the abbreviation SPECI at the very start of the message. This will be issued when the weather conditions significantly change in the period between routine observations. This can be used to indicate either an improvement or deterioration in the weather. It's perhaps worth noting that military METARs can vary slightly from civil coding rules. They'll add a colour state to the end, a code to represent cloud and visibility conditions, blue being the best and red the worst. So, now we have an understanding of how the METAR code is constructed and how to interpret their meaning. When scanning through the METARs in flight planning, it's a good idea not just to read the METARs for the aerodromes you are taking off from, visiting or diverting to, but also a station upwind of your destination. This can give a useful guide as to the conditions that may be coming your way. But how does the METAR code relate to the weather actually being experienced at an aerodrome? In this example, the synoptic chart shows a frontal depression approaching northwestern Europe, with a ridge of high pressure following to the west. An area of high pressure is centred over the Mediterranean. Firstly, let's take a look at the weather at Brussels in Belgium. We can see that Brussels is to the east of the approaching warm front. The surface wind will be roughly southerly, around 10 knots. The cloud will be thickening and lowering as the front approaches, but at 12Z there is no weather, and the cloud base is above 5,000 feet. As such, the METAR gives CAV-OK as the conditions. It's important to note that CAV-OK gives no indication of the poorer weather conditions on the way. This is indicated in the trend. There are 4 other airports on this chart: Paris, Brest, Shannon and Madrid. Each of these stations will be highlighted and displayed. Then 4 different METARs will appear: A, B, C and D. When each station is shown, select the appropriate METAR which you feel best fits the weather at that station. The first of these stations is Paris. Please select A, B, C or D. Correct. The next station is Brest. Please select A, B, C or D. Correct. The next station is Shannon. Please select A, B, C or D. Correct. The next station is Madrid. Please select A, B, C or D. Correct. It's important to remember that these examples are generalizations. No 2 synoptic situations are ever the same, and conditions can, and do, vary greatly. The main reasons for this are geographic location and orography. In exposed mountain regions, winds will tend to be stronger and more gusty. Temperatures will tend to be lower, and with hill fog more prevalent. The main reasons for this are geographic location and orography. In exposed mountain regions, winds will tend to be stronger and more gusty. Temperatures will tend to be lower, and with hill fog more prevalent. Similarly, coastal areas will be windier, and in some locations more prone to fog rolling in from the sea. In winter, showers will be more common on windward coasts than inland regions, and at certain times of the year may experience sea breezes. Inland areas tend to be more sheltered, although daytime maximum temperatures will be greater, and nighttime minimum temperatures are lower. In the summer, these areas can also be more prone to showers and extreme convective activity, such as hail, thunderstorms and tornadoes. Sheltering effect can also be observed, mainly to the lee ground. Good examples of this can be found in Aberdeen, to the east of the Scottish Highlands, and in Denver, to the east of the Rockies. Another way an aviation hazard may be notified or forecast is by the use of the airfield warning system. The details of this system vary at different aerodromes, so local rules apply. However, it's still well worth being aware of these warnings, as they can add a lot to your knowledge of local conditions. This information will be covered in a lot more detail at the end of the lesson on TAFs. This now concludes the explanation on the METAR, but be aware there are many other useful sources of information which will help complement your flight briefing.